So UDP is the short term for User Datagram Protocol. It is the simplest transport layer protocol compared to TCP, of course. It has been designed to send data packets over the internet. It simply takes the datagram from the network layer, attaches its header, and sends it to the user. It doesn't guarantee that data will arrive at all. It doesn't have an error checking mechanism. The header size is small compared to TCP. It is faster than TCP. It is best used for applications that require speed, such as online streaming and video games. The following diagram represents the UDP header format. It has a source port, destination port, length, and checksum. This represents the UDP header in size, as you can see, 2 bytes for each. Now let's go to Wireshark and see how UDP works there. So I'm here in Wireshark. I'll open SMB capture. You can open any file and search for example, DNS traffic. Because as you know, DNS works on top of UDP. So here we get some DNS frames. So just press on any one. If you go down below, you will see User Datagram Protocol. Just expand that. You will see the headers that we've just explained. The source port here is a 16-bit field. It identifies the port of the sending application. The destination port is 16-bit field as well, or 2 bytes. It identifies the port of the receiving application. Length equal the length of the UDP header, which is, if you press here, it's 8 bytes in size, plus the length of the encapsulated data below. If you press on the DNS system, you'll see in the bar below, it's 121 bytes, and the UDP is 8 bytes, totaling to 129 bytes. The checksum is a 16-bit field used for error control. It is calculated on the UDP header, encapsulated data, but in UDP, a checksum calculation is not mandatory. To name some of the well-known applications used by UDP, as we've seen here, it's DNS. We have some routing protocols as well, such as RIP and OSPF. We have TFTP, which is the Trivial File Transfer Protocol. We have a broadcasting and multicasting applications. Many of those use UDP. Streaming applications for multimedia, video conferencing, etc. Real-time applications like chatting, online games, and the famous SNMP protocol that is used for network management.